this case here, right? Remember this one, this guy is a quadratic function, a quadratic equation here, function. So x bigger than 4, right? This is a function. Sketch your graph f at y equals fx. Sketch should indicate clearly the position. So y equals, this is already completed a square. So at a glance, you should know what is the mean point. What's the mean point? Write it down. 4, 1, right? Okay. Then just sketch it out. Last week, okay, it's okay. You just bring your GC out. How to put the function is the domain. This is a domain. This guy, remember this guy is a domain. Domain means the input. Domain of f is x more than 4. So you put this guy, is what? X minus 4. X minus 4 square. Then you put plus 1. Okay. Remember the domain, you put the divide, then you open bracket, close bracket. This guy here, just remember that. So you, yeah, so then you just put x bigger than 4. So this is x test 4. Regardless, always put equal sign. I always put equal sign. Okay, so this is what we did last week. The domain. So you treat this as graphing techniques. Okay, because graphing techniques you use your GC, right? So then once you done it already, you can just zoom standard to the graph. Okay, any of you have any issue, let me know. This is the graph that you're looking at. This is your y equals fx. So I said this before, like when we say y equals sine x, right? Ask you to find the inverse function. Inverse function just means you make x a subject. So sine inverse y equals to x, right? Same thing. If you want to find the inverse function, what you need to do, typically this is what we ask, this is a standard template. You just let y equals to the inverse, the equation there, which is x minus 4 square plus 1. So this case here, you get y minus 1 equals to x minus 4 square. X minus 4 is plus minus of y minus 1, bro. Okay. Then x is equals to either 4 plus y minus 1 or x equals to 4 minus y minus 1. How to reject? When you want to reject, very simply put it, you look at this one here. X needs to be more than 4. Okay? X needs to be more than 4. So this guy here can be, this is 4 but added the value, right? So this can be more than 4, right? So this is can. This one, you subtract. So this one reject. Okay? So this case here, you reject as x has to be more than 4. So you reject this guy. So you don't want to subtract a value out from 4. So this is the case here. You get, so hence, this is your inverse function. Remember, inverse function, we typically, you can write this down like this. This is an inverse function, but not very nice. Okay? You can make, the y is arbitrary, can be any value. So inverse function is always x becomes y becomes x. So we can write this inverse function as, it's a function of y, but you can put it in terms of x, just so that we can put on the same equation on the graph here. Okay, so this is the inverse function. This guy, the domain of f inverse is what? The range of f. So last week we touched about the range of f is the y value. The range of f. This is the range of f. Okay, this is the range of f. So the range of f here will be not inclusive of 1 to infinity, bro. Like that. Okay. Usually I just give them back the form that they gave me. So it's like that. I just follow this form here. Exactly this way of writing. Okay, so f inverse for x real value, comma, x bigger than 1. Draw the inverse function in the GC. You just put what you already found. Okay, so this guy here, I'm going to put this guy 4 plus root x minus 1 divided by x bigger than 1, bro. But I will always use the the equal sign regardless. 1 like that. So graph it will be this guy here. Okay. Now remember what I said about inverse function last week? I know probably 90% of it is gone already, but it's okay. I'll just recap again. Nobody remembers what Mr. Gan said. It's okay. It's okay, bro. I accept. Look at this graph here. What do? You, if you remember what I say, essentially this is the original equation given in the question. So understand that what we need is to make x becomes y, y becomes x. Understand? So you look at this guy here. If I copy this graph here, I take this equation, everything just change. Y becomes x. Y, then this one I change to y. This one, even for the domain, I change to y. You see, this is the graph that we get. The inverse graph will always, okay, of course, we can't key this into your GC lah, okay? Can't key this in GC. But what this signify is this equation here, the equation that we get just now, this one, okay, this one, okay? So, but we can key this into GC, that's why this is important. Then, also understand that it will always cut through the y, it was always a reflection about the y equals to x line, okay? Now, you compare this nice graph with the graph that you get from the GC, what's the difference? This one looks slanted, right? Okay, so first thing, you can just zoom out first. You go now, you press zoom out, you go zoom out first. I'll try zoom out first. You press zoom out, you see this twinkling, right? You can just go to this region here, then press enter to zoom out. Okay, zoom out to this region. You zoom out, you press zoom number 3, then you press enter again. So then you go to zoom box. Okay, remember zoom box. Zoom box is one of the most underutilized function in the GC. So you just zoom box, you go up here, you press enter. Okay, this is a graph. Okay, looks nice, right? But it's not nice at all because, firstly, understand this. You see this scale here, this 1 unit here, and this 1 unit is different length. Okay, because you see this is very nice. This is 1 1. The ratio is 1 1. How do you make this to a ratio of 1 and 1? You go to zoom. You see this zoom square here? Okay, square. 四方形. Just zoom square. Okay, the ratio must be 1 1. Go to zoom square, press number 1. Okay, this one, zoom square is useful for circle, ellipse, and inverse function. These 3 things. Circle, ellipse, inverse function. Okay? So you just press number 5. You get a very nice curve like that. Now the ratio of the scale of this x-axis and the y-axis is 1 to 1. It's the same 1 unit. Okay? So the finishing touch I always tell students is to obviously plot your y equals x line. This is the reflection line. Then the line, right, you just put dotted put like that. Put like that. Okay? Put here, then press okay. Always draw this line here. Okay, so make sure you know how to put this one. So drawing the y equals k. Drawing this line is important. Okay, draw it dotted lah. It's not part of the solution, but it helps. Remember, if this is 4 1, then the corresponding point will be 1 4. Okay, x becomes y, y becomes x. So if this is 4 1, the corresponding point on this end here will be 1 4. That's why drawing to scale is important. This guy, the mirror point here will be 1 4. Okay, this is important. So this is 1 4 here. Now, then also, now if you don't draw this properly, okay, a lot of times students draw like that. This is wrong. Okay, this is wrong. Because if this is the mirror line, you must understand that when you put your finger on the mirror, this point here, it will definitely intersect at this point here. Okay? This mirror line, nearing the mirror, you definitely will touch the mirror at this point. So they will share a common point here. Okay, so that one is important. Now you don't draw an inverse graph like that. Okay, you confirm kena penalize. So you should draw it like that. Cut this point. You should cut this point here. Okay, so this is your y equals to f inverse x. This guy, write down the equation of line in which this graph must be reflected in order to obtain this one. This will be a standard y equals to x. Part 4. How to do? So you want to find the exact solution for these two guys here. You are particularly looking at this guy here, bro. This is fx equals to f inverse x, right? You use your GC and find it. Doesn't mean that because they want exact but you can't find exact using your GC here. Okay, you can't find exact, but you can use your GC to check your answer. Okay, this later we check the exact value, we can put in calculator, you can check the answer. So how do we find this point here? Okay, so remember last week I said this in secondary school, I don't think it's a rocket science Okay, so if I got this line equation and this line equation here, if say this is y1, this is y2, this intersection point is y1 equals to y2, right? So if I got a third line like that coming down here, intersect again, so I can just write y equals y3, right? Agree? So it's the same thing happening here. I want you to see very carefully. There's another y equation here, which is y equals to x here. So this will equal to x. Okay? So when you see that they all, this one equals to this, right? If they intersect at the y equals at the mirror line, you can just self-service and add this up. It will always equals to x. Okay? It will always equals to x because three of them meet. It's a triple point. All of them meet there. Okay? They're having a party there, bro. You can pick any two to solve. Please don't tell me you pick these two and solve is easier. I hope you don't say this is easier. Okay, if you say this is easier, I don't know. You can either pick this one. Okay, you can pick any two to solve. Please don't tell me picking this is easier to solve than picking these two to solve. Okay, please. Okay, so the easiest way is to take x minus 4 square plus 1 to equal with x. Solve this. Okay, which one to reject? You reject this one. As x is bigger than 4. Okay, definitely bigger than 4 because you look at the graph, the x here is all bigger than 4. Okay, so this point here, this point, we solve already, right? This will definitely be 9 plus root 13 over 2. Because it's y equals to x, comma 9 plus root 13 over 2. Okay, so this will equal to this.